Hello everyone, welcome back to the channel. I hope you guys are doing pretty well. So we will see today's daily challenge on Leetcode and let's discuss it together. So we have this problem, minimum number of flips to make a binary string alternating, okay? So you are given a binary string S, you are allowed to perform two types of operation on the string in any sequence. The type 1 operation is that remove the character at the start of the string and append it to the end of the string. Or pick any character in S and flip its value. So if its value is 0, it becomes 1 because it's a binary string. And return the minimum number of type 2 operations that you need to perform such that S become alternating. Okay. So only the type 2 operations you need to minimize, and type 1 operation you can do as many number of times as you want. And the string is called alternating if no two adjacent characters are equal. So if the string, if you look at these strings, 10010 and this 1010, these are alternating, and I hope you do understand this. Okay, it's very simple. And in this example one, if you try to see, use the first operation two times to make this string. So the first operation is that you can remove a one from the beginning and append it at the end. Okay, and if you remove the two ones from the beginning and append them at the end, you get this string, and then you change this value of the string. The index number 2 you change from 0 to 1, and the last one you change from 1 to 0, and the resulting string you get will be 101010, which is an alternating string, and you use two operations for this. Okay, so I hope the problem statement is now at least very clear to you. There should be no doubt in the problem statement, and let's try to understand the solution. I hope you will try it on your own first and then only continue watching the video. So these examples are not much good. The reason is that if you see 111000, and if you try to do something like change this 1 to 0, okay, and again change this 1 to 0 without doing any kind, this one, okay, not this one, without doing any kind of flip, you directly got 101010. So that is also an answer too. So this is not a very good example. Let's take some other example. Okay, so let's take this example 101 1010. Okay, let's take this example. You want to make this string alternating. Okay, so you can apply the type 1 operation infinite number of times, and type 2 operations you need to this is nothing, type 2 is nothing but bit flip. Okay, so if this is infinite, this you need to minimize. Okay, this you need to minimize. So you see type 1 operations involves taking this bit and writing it at the end. Okay, writing it at the end. So if you do it one time, you get something like 0 1 1 0 1 0 and 1. So you just bring this one over here, then you try to bring this 0 over here, and then you try to bring this 1 also over here. So do it in the same stretch. Okay, so you bring the 0 first and then you bring the 1 first, and you see this string is alternated by only using type 1 operations. Okay, so this is a very special kind of string. I hope you do realize that using only type 1 operation also you can make the string fully alternating. And so what will be the answer for this? The answer will be 0, because the type 2 operations you did not need any bit flip. Okay, the number of bit flips were 0 in this case. Okay, so but I hope you do understand that we need to shift this. And if you try to see another example very similar, so let's remove this 0 from here. Okay, remove this 0 from here and then try to see. Okay, so you see in this string, no matter what you do, like if you try to place this one over here, this one will come at the front. Okay, if you try to move this 0, again you will get something like this. So you see this one was alternating, but by bringing another one over here, you are making it more bad. Okay, so there is no use of any shifting over here. Okay, there is no use of any shifting. And if you try to see how many operations you need, you can just see, you can change this bit to 0, this bit to 1, this bit to 0, and you will get 101010. This will make you an alternating string, but the answer will be 3, because number of bit flips you require will be 3 in this case. And I hope you do understand that by now one thing, that if the front bit and the last bit are the same, and if you try to put the front bit at the last, then there is no use of that. No use of that, because you are essentially making something which is good. So if something is good like this, you are making something which is more bad. Okay, so you do not want to be something like this. Okay, and one thing you can realize that if you are told that you are given some string, let's say 1011, something like that, random, and you want all possible configuration by shifting, you want to see that all possible things which are possible by shifting, so you can write something like this. Okay, so again, if you try to shift this one, you will get something like this. Okay, again you try to shift this 0, you will get something like this. So the thing is that I am trying to show you all possible configurations, that if you consider the string which is given to you as a circular string, that is after the end you have the first index. Okay, so if you consider this as a circular string, that is essentially you write this string two times. Okay, so you write this string two times, 110101. Okay, so you are writing this string two times, and if you want to get all possible configurations of this by type 1 operations, all you need to do is take a sliding window and shift it. Okay, so again take this sliding window, shift it. So in this way, by shifting the sliding window, what are you getting? You are getting all possible configurations. Okay, you are just getting all possible configuration by performing type 1 operations. So it will be something like, again, now let's come to our example. We saw that, yeah, this example we took at the first, and we saw that if we do the type 1 operation three times on this string, so you take this portion and put it at the end, whole of this portion, you will get an wholly alternating string. Now again, you must notice that in this example also, the first bit and the last bit are different. That is why you are trying to do this. And if you try to write this two times, okay, if you are try to find all possible configurations by writing this string again two times, 101 and 1010. Okay, did I do it correct? Yeah, I did it correct. Now in order to get all possible configurations, what you need is a sliding window, as I told you, for this 7 length. Okay, now you see this 7 length window. Again, this will be another possible configuration, this will be another possible configurations, and this particular configuration, if you try to see, all of the string will be alternating. Okay, so this whole string will be alternating in this configuration, and you will see that you can just so I hope the approach is very clear to you. Just write the string two times, okay, in the front. So you can do s equal to s plus s, that will concatenate the string two times, and you just take a sliding window of length, which is the length of the string. Okay, initial string, definitely this is n, so after this it will become 2n. So you take the sliding window of length n. Okay, and what do you need to find? Can you tell me what do you need to find by taking a sliding window? All you need to find is that the maximum series of alternation. Okay, so you see 10101, the maximum series of alternation is this 10101. Okay, and in this example, the maximum length of this alternation is for 7. Okay, and the length of the string is also 7, so number of operations is 7 minus 7 0. Okay, so I hope it is very clear to you. So you can simply shift the sliding window. So one approach can be to simply shift the sliding window. You should do this approach on your own. I will show you another method using XOR. So shift this sliding window and of length n. Okay, of length n. So you are shifting the sliding window of length n, and finding the longest alternation. As simple as that, because in all possible configurations you find the longest alternations, and if you get some alternation which is less than the length of 7, then how many bit flips you require? You require less number of bit flips. Now one thing is that in alternations, one thing is that you can only reach two types of alternations. Okay, one is, so if you are given one string something like this, if you try to make it alternating, you can reach only two types of string. One is 101010. Okay, another is 0101. So there is no possible, no, I mean, no other choice apart from these two. Okay, So that's what you need to do. And what I will suggest you to do is that use a XOR. Okay, so yeah, how can we do this using XOR? If you try to write that string again, 101 101 0, and again you are writing 101 10 10. Okay, and what I'm telling you is that your final configuration of the string should look something like 10 10 10. Okay, 1, and again, or you can just alternate the whole thing, so 0 1 0 1 0 1 0. Okay, so yeah, this is the whole alternating string, or the thing which you can reach is 0 1 0 1 0 1 0 1 0 1 0 1 0 1. So if you try to perform a XOR, so let's perform a XOR with these two. Okay, let's perform a XOR with these two. What we will get? What we will get as the answer? You see, XOR will be 0 0 0 for the first three, and the next it will be 1 1 1 1, and then again it will go 1 1 1 0 0 0 0. Okay, so yeah. And you see that this is your resulting string. If you would have performed XOR between these two, taking these two as the example, you will get a similar string. You will get 1 1 1 0 0 0 0 0 0 0 1 1 1 1. So if you perform XOR between these two strings, you get this answer. If you perform XOR between these two strings, you get this answer. And essentially, you see they are the complement of each other. So you it is sufficient to take just one of the string. So let's take just one, the alternation which starts with 1. Okay, we will take this alternation and XOR with that. And again, in this string, see your question. Now your thing becomes more simplified, is that you can keep another sliding window of length of the string n. Okay, and you can shift this window, and you just check that in which window you are getting the maximum length of ones or. Okay, so maximum number of same bits, you check the maximum number of same bits. I hope it is very evident from this example only. So you see, whenever you get the maximum number of same bits, so you take that length as your max. Okay, then you do n minus length, because those are the bits where you do not need to flip. They are already alternated by just doing the type 1 operation. So again, I am writing this string 2 times because I am exploring all possible configuration obtained by type 1 alternations. Okay, so and maximum number of same bits. I hope you do realize what I'm trying to do, and you can do just n minus len. Okay, so I hope this is only the approach, and you are very clear with this. You should be very clear. N minus len only you need to do. So yeah, this just gives you the whole string. So the zero operation 7 minus 7. So you can go ahead with this. So let's do the coding portion. We can do s dot size, and we again have something like s equals to s plus s. Okay, and what else? Let's have the result. So let's have a string result. Okay, we will store this values, the result, whatever the result of obtained after doing the XOR. Okay, and let's now go through all the elements in this string. So 2 into n, length of the string has now become 2 into n. And if you see something like let's say if I and 1, so what does this mean? This means that if I is odd. Okay, if I is odd, what you do, you, let's say, do any of the things. So result plus equals to, you append a to string of uh, 0. So I am doing a XOR, right? So 0 XOR with uh, s of I. Okay, 0 XOR with s of I, and you, in order to make it a character, you can just add so in by it is also feasible if you do not write this to string and write this simple character. Okay, so I hope you do understand that this makes this whole thing a character. Adding this simply makes the whole thing a character. And you get it. And else, so you are just doing this XOR with alternating string. Okay, so if the index is odd or even whatever, you do one XOR with 0, and otherwise for the other alternate indices, you just do 1. Okay, and definitely you need to subtract this 0, don't forget this, because it is in character form, you bring it into integer form. So yeah, that's what, if the place is odd, so this I and 1 tells you that if it is odd, the you XOR with 0. Okay, so it means that for you are considering the string of type 1010 1010 alternating. Okay, this is only I'm considering, and I'm performing a XOR with that only. Okay, so yeah, you have the result with you. So you see, just by doing this, we have this final result with me. We have this final result with me. All I need to do now is shift this sliding window and just check uh, what is our maximum number of same bits. Okay, so uh, we will have an int len, okay, which is nothing but the maximum number of same bits only. And first window length I will just calculate with this. Okay, so for int I equals to 0, I less than n, I plus plus, if okay, so let's have another variable int zeros. So not zeros, let's call it ones. And if a string is 1, I will just increment this one. So if s of I is equals to 1, I will just add this ones plus plus. Okay, hope there is no doubt in this. And yeah, ones plus plus. And what will be len? Len will be nothing but max of ones and n minus 1. Okay, I hope you do realize why I'm trying to do this, because yeah, I will need the maximum number of same bits. So if ones may be maximum or n minus ones is the number of zeros, this is nothing but the number of zeros. So whichever is the maximum, I just put it in the len. And now we can start the sliding window. Okay, so start from any I equals to n, I less than 2 into n, I plus plus. Okay, and what do you do for this? You see that if again s of I is equals to 1, you can just increment your 1. And if you see that, see, you are shifting one window. Okay, so this I minus n index, now essentially you need to remove it. Okay, but now if I minus n index, since you are removing it, if it was 1, you need to decrease the count of 1. Okay, and you can just update this length value. Okay, max of uh, len ones and zeros. Okay, zeros is nothing again but n minus ones. So yeah, you have this, and you can just simply return n minus len is your answer. So I hope there is no doubt in this, and yeah, that is all. I hope it is very clear of what I did, and if you try to submit it, I hope it will work just fine without any errors. So yeah, we are getting a wrong answer. So let's see where did we mm, got stuck. Okay, so let's try to debug. Okay, so you try to see here that S, if you see, we should not check this S, we should check this result. Okay, because that is the string, right? Yeah, so this was one error. So let's try to run and see if it works. Uh, Again, we are getting something. So let's see. If result of I minus n is 1 minus minus, and we have a string result. If it is odd, then do a XOR with 0. So odd indices, it does a XOR with 0. And even indices, it does a XOR with 1. uh, len is 0, ones is 0, and we increment the ones here. Yeah, so again, this same thing, I guess. This is should be result and not F. So yeah, mm, yes, yes, yes. So yeah, we have the accepted thing. I hope you do understand. So yeah, let's try to see. Yeah, it works for all test cases, and we have a decent runtime complexity. If you think of the time complexities is nothing but O of 2n over here and an n over here and another n over 2n over here. So O of 5n, or essentially O of n, is only our time complexity. And I hope this problem was pretty clear and no doubt for this. If you have any doubts, you can definitely ask me in the comment section. Yeah, that's all. That's all for this video. I will meet you in the next video. Till then, thanks a lot.